Bismillah ar-Rahman ar-Rahim. Inshallah, we'll try to deal with 3.8. See what we have in this one. Yeah. Okay. So what we have, if I want to approximate the zero of a function, so I have f of x equals 0. I want to find, not to find, to approximate the 0. Approximate the x which satisfies f of x equals 0. So you need to start with x equal x1 with some point nearby this x. Then we need to apply this formula, xn plus 1. It will be xn minus f of xn over f prime of xn. So we'll do what's called the iteration to find x2. Then you plug x2 in the equation to find x3, and so on. So this is what they call the iteration. When you will stop, if the difference between x and iteration number x n plus 1 and the one before it is less than the error which you are looking for. You use epsilon for small numbers. Okay. This formula is the condition for convergence. It means if the function, we're talking about the function, satisfy this, if the function satisfy this, where you will put x in the starting point, your x1. If you put it there, then for sure you will get the convergence. I will do small problems about these things because this is new. Okay. Now, let me, as usual, I'll try with the simple problem to understand what we have. Mainly, we have this formula. That's it. The rest is just calculation. Okay. So use the Newton's method, and it means the Newton's method to find x3. So I need to find not the first iteration, second one. Huh? I need to do 2 iterations. Okay. So I have the formula. I have x1 equal 1, and f of x is x cubed minus x squared minus 1. Then I need f prime, which is what? 3x squared minus 2x. Okay. According to the formula, let us write the formula here. Xn plus 1, xn minus f of xn over f prime of xn. Okay, so x2 will be x1 minus f of x1 over f prime at x1. And that x1, which is 1, minus f of 1 over f prime of 1. Okay. F of 1, plug it here. Have 1 minus 1 minus 1, so that will be minus 1. F prime at 1, it will be 3 minus 2, which is 1. 3 minus 2, which is 1. So I have 1 plus 1, and that is what? 2. So now we'll do next iteration, x3, which is x2. What then by iteration? Now I get x2 equal to, this is my starting point now. Plug it here. That will be 2 minus f of 2, which is 8 minus 4 minus 1. That will be 3 over f prime. Let me make it, since it's the first problem, f of 2 over f prime at 2. That would be 2 minus 3 over f prime of 2. What would be that? 12 minus 4, which is 8. Yeah, do the calculation. That would be what? 16 minus 3, 13 over 8. So this is my second iteration. That will be x3. That's mainly what we will do. We'll do now problems. It's going around the same idea. If Newton's method is used to approximate the x coordinate, what do I mean by x coordinate? Means y equals 0 of the point of intersection they want, yeah, the point of intersection of these functions, y1 sine x plus y over 2 and y2 ln 2x plus 1. Okay. Point of intersection means I want them to be equal to each other. Don't forget, always to use Newton's method, I need to find something equal 0. So what I will do, either I'll take y1 to this side or y2 to this side. So I have y, which is y1 minus y2 is equal to 0. So I have y of x is y1, which is sine x plus y over 2 minus ln 2x plus 1. This is what I want to find the 0 of. We want to approximate the 0 of this one. Approximate the zeros of this one. So what I will do, I will apply Newton's method to this function. So I have y prime will be what? Cosine x plus y over 2 minus, here I have what? 2 over 2x plus 1. My starting point x0 equals 0. That implies x1 will be x0 minus f of x0 over f prime at x0. Plug the numbers. That will be 0 minus f at 0, which is y in this case. So this is, we call it f of x. Let me call this f of x. So this is f of x, we call it. It's just names. At f prime at 0. Okay. F of 0 is what? I have sine pi over 2, which is 1, minus ln 1, which is 0. So it will be 1 over. F prime at 0, cosine pi over 2. Cosine pi over 2 is what? 0 minus 2 over 1. So it will be minus 2. So the answer is half. Half, which is what? 0.5. So this is the answer. So what's new? They want talking about the point of intersection. When I want to apply Newton's method, I need function equal 0. I need to find it's used to approximate the zeros of a functions. The zeros of a function. Okay. Yeah, I'll go back to this question. Let me do some problems, and then I'll go back to these questions. You use to approximate the root of the equation with first approximation this, find x2. Most of the problems are like this. So what will be f of x? 2 over x minus x squared plus 1. So that means f prime will be what? Minus 2 over x squared minus 2x. I have x1 equal 2. That implies x2 is x1 minus f of x1 over f prime at x1. And that will be 2 minus f of 2 over f prime at 2. Okay, do the calculation. 2 minus. From here, what will be f of 2? 1. 2 over 2 is 1 minus 4 plus 1. And that it will be minus 2. So this is minus 2 over. From here, what is f prime at 2? It will be minus 2 over 4 minus 4. And that will give me what? That will give me, this is half minus 9 over 4. Okay. Yeah. Minus half minus 4 minus No, minus 9 over 2. I mean, what is this? This is minus half minus, which is 4 minus 8 over 2. So it's minus 9 over 2. So this one over minus 9 over 2. So that will be 2 plus 4 over 9. 2 minus 4 over 9, sorry. 2 minus 4 over 9. Minus, 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 so it's minus. That will be what? 18 minus 4, 14 over 9, which is this one. If we want to use approximation to approximate the solution of this equation, 2x minus cosine x equals 0 minus 3 cosine x. So my function is this one. Derivative is 2 plus 3 sine x. Okay. Starting point, x1 equal pi over 2. That implies x2, x1 minus f of x1 over f prime at x1. That will be pi over 2 minus f of pi over 2 will be what? Pi cosine pi is minus 1, so pi plus 3. So this is pi plus 3. F prime of pi over 2 will be what? 2 plus 3, which is 5. So this is over 5. Okay, so this is over 10. I have 5 pi minus wait a minute. No. What is this? No. F of pi over 2 will be pi cosine pi over 2 is 0, not 1. Sorry, cosine pi over 2 is 0, so it will be pi only. So this is pi. Sorry for that. This is pi, so I have over 10, 5 pi minus 2 pi, which is 3 pi over 10. You need to be careful about the calculation. Let me back to this question. Well, it's a little bit different. What I have here, I have the function, but I have constants, a and b, unknowns. Okay. Now, then he gave me x1 equal 1 and x2 equal 5 over 6. What will be x2? x2 is x1 minus f of x1 over f prime of x1. So what is my function here? A x to the power 4 plus b square. That means f prime is 4a x cubed, 4ax cubed plus 2bx. Correct? Yeah. So x2, which is 5 over 6, equals x2. That will be 1 minus f of 1 over f prime at 1. So that implies 5 over 6 equal 1 minus. What is f of 1? F of 1 is a plus b. What is f prime at 1? It will be 4a plus 2b. So that will be 4a plus 2b minus a minus b over 4a plus 2b, which is equal 5 over 6. That will be what? 3a plus b equal 4a plus 2b. That implies, and we have 20a plus 10b equal 18a plus 6b. That implies in 2a equal minus 4b. That implies a equal minus 2b. So I have this relation. So I need to check which one is correct. If B equal 1, I put it in B equal 1, A should be what? -2. This is wrong. If B equal 2, A should be -4. This is wrong. If B equal 0, A should be 0. This is wrong. If B equal -1, A equal 2. This is wrong. If B equal -half, A will be what? 1, which is the only solution, the only correct option. Can he said possible values because they have just a relation. Any two values satisfying this will give me this x1 equal, if x1 equal 1, then x2 equal 5/6. Okay. Using Newton's method, usually this is find x2. He gave f of x. F of x cubed minus 2x minus 5. F prime, I need f prime, 3x squared minus 2. x1 equal to x2, x1, f of x1 over f prime of x1. 2, f of 2 over f prime at 2. 2 minus f of 2 will be what? 8 minus 4 minus 5, that is -1 over f prime at 2. 3 times 2 times 4, 12 minus 2, that will be 10. So it will be 10 plus 1 over 10, which is 2.1. Using this method to find the initial approximation, the second approximation to the root of this equation. خلاص. So it will be f of x to the power 7 minus x to the power 6 minus 2. F prime 7x to the power 6 minus 6x to the power 5. Okay. Now x1 equal 1, x2, x1 minus f of x1 over f prime at x1, and that is 1 minus f of 1 over f prime at 1. That will be 1 minus f of 1 is what? 1 minus 1 minus 2. That is -2. F prime at 1, 7 minus 6, that is 1. So I have 3. Most of the problems are this. This is my f of x. You want x3, huh? You want x3. F of x is x cubed minus 2x minus 1. F prime 3x squared minus 2. خلاص. And x1 equal 1. That means x2, x1. That will be 1 minus f of 1. That 1 minus, I have 1 minus 1 minus 2. That is -2 over the prime of 1, 3 minus 2, which is 1. That will give me what? 3. Now, x2 equals 3. That implies I'm not looking for x2, I'm looking for x3. That implies x3 will be x2 minus f of x2 over f prime of x2. That will be 3 minus, sorry. That will be 3 minus f of 3 over f prime at 3, which is 3 minus. F of 3, substitute here. F of 3 will be what? 27 minus 7. 27 minus 6 minus 1 minus 7. So it's 20 over f prime at 3 from here. F prime at 3 will be 25, which is 27 minus 2, 25. So that will be 3 minus 4 over 5. By divide by 5, it will be 4 over 5. So that give me what? 15 minus 4, 11 over 5, which is this. Use the approximate this. So this is my function, my starting point, my function, f prime 3x squared minus 1. I have x0 equals 0. That means x1, I need first the first x1, then I'll find x2. So the second one, huh? x1 will be x0 minus f of x0 over f prime x0. And that will be 0 minus f of 0 over f prime at 0, which is 0 minus f of 0, which is 1, f prime at 0, which is minus 1, so that will be 1. So x1 equal 1, x2 will be x1 minus f of x1 over f prime at x1, which is 1 minus f of 1 over f prime at 1. That will be 1 minus f of 1, 1 minus 1 plus 1, 1. F prime at 1, 3 minus 1, which is 2. So that will be half. Just this one. Use the Newton's method to find the root of this equation. What is my first step? Make it equal to 0. So I have x to the power 4 minus x minus 1 equals 0. So my function is this one. My derivative is 4x cubed minus 1. I have x1 equal 1. That implies x2 is x1 minus f of x1 over f prime at x1, which is equal 1 minus f of 1 over f prime at 1, 1 minus عند 1 minus 1 minus 1 at f prime of 1, 4 minus 1, 3. So it will be 1 plus 1 over 3, which is 4 over 3, which is this. Using this method with x1 equal to, find the second approximation. What is my first step? If you want x2, given x1, find x2. X equal 4 minus 4x plus 2 equals 0. This is, so my function is this. My first step, I should make it equal to 0. Now we'll find f prime. That will be 3x squared minus 4. x1 equal 2. That implies x2 is x1 minus f of x1 over f prime at x1, which is equal to minus f of 2 over f prime at 2. Is equal to minus f of 2. I have 8 minus 8, 2 over here 2, 12 minus 4, 8. So it will be 2 minus 1 over 4, which is 7 over 4. Using this method, approximate the solution of this. My first step, make it equal to 0. So my function is this. Find the derivative. That will be cosine x plus 2 sine 2x. Okay. Be careful for the calculation. x1 equal pi over 4. That implies x2 is x1 minus f of x1 over f prime at x1. And that is pi over 4. F of pi over 4 over f prime at pi over 4. Yes. That will be pi over 4 minus. Okay. F of pi over 4. What will be f of pi over 4? Sine pi over 4, which is square root 2 over 2, minus cosine 2 times pi over 4, cosine pi over 2, which is 0. So that will be root 2 over 2. Over. Now this one, f prime at pi over 4. That will be equal to what? Cosine pi over 4, which is root 2 over 2, plus 2 sine pi over 2, which is 1, plus 2. So that I have square root 2 over 2 plus 2. Simplify. That will be pi over 4 minus, I have root 2 over 2. This one I have what? Root 2 plus 4 over 2. So these two cancelled. So it will be pi over 4 minus root 2 over root 2 plus 4, which is this one. Using Newton's method to estimate the value of this. Cube root of x7. There is no equation. I let x cube root of 7, x cubed equals 7. So my equation is this. So f of x is x cubed minus 7, which will give you this 0, cube root of 7. F prime is 3x squared. Starting with x0 equal 1, with x0 equal 1, I want to find x1. x1 will be x0 minus f of x0 over f prime at x0. That will be 1 minus f of 1 over f prime at 1. That will be 1 minus 7, which is minus 6 over 3. That will be 1 plus 2, which is 3. So that will be 3. If this method is used to find the critical number with initial this, you want x3. Be careful. I want to find what? The critical number for this function. Until now, we did not do 4.1, but we just did it actually. Critical number means f prime equals 0. And there is no need. F prime does not exist because this is polynomial, so the derivative for sure exists. So the equation I'm working with this is no need because this is a polynomial. The equation which I need to find the 0 of it, or I need to solve f prime equals 0. What is the f prime? That means I need to solve 6x to the power 5 minus 3x squared plus 2x minus 2 equals 0. So my function, which I am working with, is this function. To find g prime, which I want to apply Newton's to, I want to apply Newton's method for this function, not for f, because I need the critical number. I need the derivative of that f. So g prime will be 30x to the power 4 minus 6x plus 2. Khalas, I have x1 equals 0. That implies x2. You want x3. It means we need to do it 2 steps. x2, this is x1 minus f of x1 over f prime of x1. That will be 0 minus f of 0 over f prime of 0. F of 0 is minus 2. F prime at 0 will be 2, so that will be 1. x2 equal 1. That means x3 is what? x2 minus f of x2 over f prime at x2. That will be 1 minus f of 1 over f prime at 1. That's 1 minus f of 1. F of 1, that will be 6 minus 3 plus 2 minus 2. That will be 3 over. Here I have 30 minus 6, 24 plus 2, which is 26. So that would be 23 over 26, which is this. I'm looking for x3. The same idea, I want to estimate what? The critical number. So I want to estimate the g prime. So g prime, first I will find g prime. And g prime is what? 6x to the power 5 plus 30x plus 30. That's my g prime. I will call it of x. So I'm working with this function of x. Since I want the critical number, I need g prime equals 0, or g prime does not exist. But this is, I will not look at it because it's a polynomial. So g impossible to be the derivative does not exist. So I'll work with this f of x. What will be f prime? That will be 30x to the power 4 plus 30. Okay. Now I have x1 equals 0. x2 will be x1 minus f of x1 over f prime at x1. That will be 1 minus f of 1 over f prime at 1. No, x prime, that will be 0, 0. Why, what's from everything this one? 0 minus f of 0, f prime of 0. It's 0. That will be 0 minus f of 0. 30. F prime at 0, 30. That will be minus 1. So x2 equal minus 1. That implies x3, x2 minus f of x2 over f prime at x2. That will give you minus 1 minus f of minus 1 over f prime of minus 1. That will be minus 1 minus. Okay. Now f of minus 1, substitute here, f of minus 1, that will be minus 6 minus 30 plus 30. So it was minus 6 over f prime at minus 1. That will be what? 30 plus 30, which is 60. That over 60. So I have minus 1 plus 1 over 10, which is minus 0.9, which is minus 9 over 10, which is minus 9 over 10, which is minus 0.9, which is this one. Okay. Starting with x1 equal this, find x2 for this function. Direct. What will be f prime? It will be 7x to the power 6. I have x1 equal minus 1. That means x2 is x1 minus f of x1 over f prime at x1. That will be minus 1 over f of minus 1 over f prime at minus 1, which is minus 1 minus. F of minus 1, I have 3, because it will be minus 1 plus 4, 3, over 7. That give me what? Minus 7 minus 3 over 7, minus 10 over 7, which is this one. Newton's method we used to do this. I think I did it before. Yeah, we did it before, I think. If I remember well. Yeah, which is this one. So I did it before. Done before, huh? Okay. The resultants. If we use Newton's method to approximate the root of this equation, with the initial condition this, find x2. So what is my function? Is x squared minus x minus 1, and to find the root of this. Root means then to make this equal to 0. This is what I'm looking for. So f prime be 2x minus 1. I start with x0 equal 1. So that means x1 is x0 minus f of x0 over f prime at x0. That will give me 1 minus f of 1 over f prime at 1, which is 1 minus f of 1, 1 minus 1 minus 1, that is minus 1 over f prime at 1, which is 1, so that will be 2. Now x1 equal 2, so x2 equal x1 minus f of x1 over f prime at x1. That will be 2 minus f of 2 over f prime at 2. That will be 2 minus f of 2, 4, that is 1 over 4 minus 1, this is 3. So that will be 5 over 3. 6 minus 1, which is 5 over 3. Using Newton's method with initial guess, this, he want what? 2 iterations. So he want x2, also he want x3. So he want x2 and x3. So it is function x cubed minus 7, f prime is 3x squared. So x2 would be x1 minus f of x1 or f prime at x1. I have x1 equal 1. That will be 1 minus f of 1 over f prime at 1. That will be 1 minus f of 1, 1 minus 7 minus 6, f prime at 1, 3. So that will be 3. So x2 equal 3. So x3 will be x2 minus f of x2 over f prime at x2. That will be 3 minus f of 3 over f prime at 3. And that will be 3 minus f of 3, 27 minus 7, which is 20, over f prime at 3, 27. So that will give me what? 27 times 3, which is 81, minus 20 over 27, which is 61 over 27, which is this one. Okay, starting with x1 equal this. This is the function. And what will be f prime? 3x squared minus 2, x1 equal 2. So it means x2 is x1 minus f of x1 over f prime of x1. That will be 2 minus f of 2 over f prime at 2, which is 2 minus f of 2. F of 2 is what? 8 minus 4 minus 5, that is minus 1 over f prime at 2, 12 minus 2, which is 10. So I have 2 plus 1 over 10, which is something similar, 2 point, which is this. By using Newton's method to do this, dealing with this function, x cubed plus x minus 1 equal, yeah, this is my f of x. F prime of x is 3x squared plus 1. So I have x1 equal half. That means x2 is x1 minus f of x1 over f prime at x1. That will be half minus f of half. Let me do it here. F of half is 1 over 8 plus half minus 1, which is 1 over 8 minus half, which is minus 3 over 8. Okay. Yeah, this is 4 over 8, so it's minus 3 over 8. F prime at half, that will be 3 over 4 plus 1, which is 7 over 4. So that will be half minus 3 over 8 over 7 over 4. That will be half minus 3 over 8 times 4 over 7. 1, this is 2. So that will be half plus 3 over 14, which is what? Which is 7 plus 3 over 14, which is 10 over 14, which is 5 over 7, which is this. Yeah. Now, I want to explain more this formula, which is this one, the convergence. It says what? If we f double prime or f prime square. Let me write it here. I want this to be less than 1. Okay. So let me deal with this one, which I know Newton's method converge. In this case, converges, yeah. So what will be f prime is 2x. What is f double prime is 2. Now let us see the formula. It will be f of x, f double prime of is less than 1. Less than 1. F double prime of x over f prime of x square, which is what? X squared minus 2 times 2 over 4x squared. In other words, it's 1 over 2 minus 1 over x squared. Now notice, if we start with x1 equal 2, what we will get? We'll get half minus 1 over 4. And that will be 1/4, which is less than 1. So we'll have a convergence. So convergence. If you have other values, if you want to find the values where we have full convergence, you need to solve this inequality, which is a little bit complicated. But if you have a starting point, I can check there is a convergence or not. Okay. This case, which I know there is no convergence. Actually, if we do it, I have, let me do, by the way, I think this is with it. Now I have f prime is 1/3 x minus 2/3. And so if I apply the Newton's formula, I have xn plus 1 is xn minus f of xn over f prime at xn. And that will be xn minus f of xn, which is xn to the power 1/3 over. This one is what? 1/3 x minus 2/3. So that'll give me what? Xn minus 3xn. Yeah, this will go up, so it will be xn. So I'm getting what? Minus 2xn. So it means if I start with x1, 0.1, x2 will be what? Apply it here. I have x2 will be minus 0.2. x3 will be 0.4. x4 will be minus 0.8. I know that the 0 is 0, so I'm going far away from this. So now if I check this formula, I need f double prime. Huh? F double prime would be what? Minus 2/9 x to the power minus 4/3. Okay, so now check this formula. F of x, f double prime of x over f prime of x squared for this case. That will be what? We say no, there is no convergence, no convergence. Okay. So I have f, which is x to the power 1/3 times f double prime, which is minus 2/9 x minus 4/3 over this one square, which is 1/9 x to the power no, sorry, this is not 4/3, minus 5/3. Yeah, so this is minus 5/3. Minus 5/3. This is x to the power minus 4/3. And that will give me minus 2/9 minus 2/9 x is minus 4/3 over 1/9 x is minus 4/3, which is always will give me 2, which is not less than 1. So I cannot guarantee convergence. We cannot guarantee convergence. Okay, now let me do the problems in the book. The most difficult things with the problem in the book is that most of them, they are, I need the calculator. So I will do it. And when there is a need for the calculator, I will just get the number by the digits. Okay, first one. In exercise 3 to 6, calculate 2 iterations of Newton's method to approximate a zero of the function using the given initial guess. He gave you the initial guess, x1 equal 2. So I have f prime is 2x. The initial guess is this. So I have x2 is x1 minus f of x1 over f prime at x1. And that will be what? 2 minus f of 2 over f prime at 2. That will be 2 minus f of 2, 4 minus 5, that is minus 1 over 4. So it will be 2 plus 1 over 4, which is 2.25. So if you plug this, now x3 will be x2 minus f of x2 over f prime at x2. He said they want two iterations. Huh? So I'm doing this is the first one, this is the second one. If you plug the number 2.25, you plug it in f, you plug it in f prime, you'll get the answer like this one, which we cannot do without the calculator. Now this one, what will be f prime minus sine x? I have x1 is this, x2 will be x1 minus f of x1 over f prime at x1. We do the calculations. That will be 1.6 minus f 1.6 over f prime 1.6, which I need the calculator to do. We did the substitution. We get this number, 1.5708. Do the same for x3. And we will get, so I plug this number and we did the calculations. We get the same. Yeah, we get the same, 1.5708. Okay, and exercise 7 to 8 use this image to approximate the zeros of the function, continue the iterations until two successive operations differ by less than. So I want xn plus 1 minus xn less than 0.001. Okay, let me do number 9. As I said before, we cannot do it without the calculator. X cubed plus x minus 1. What will be f prime? F prime will be 3x squared plus 1. And let me start with x1 equal half. So x2 will be x1 minus f of x1 over f prime at x1. If we do the calculations, we get 0.7143. This is 0.5. Very clear, x2 minus x1 is not less than 0.001. So let me do x3. x3 will be what? x2 minus f of x2 over f prime at x2. We did the calculations using the calculator. We get what? 0.32, which does not satisfy this. But if we do x4, we get this. Point. Let me check it. This is question 9. We did x4. 0.6823, which is satisfy what I want. Okay, satisfy what we want. So x4 less than 0.001. Okay, 11. F of x 5 square root x minus 1 minus 2x. To find the zeros, I need to find the intersection of these two. Or sometimes how to choose the starting point. I need to find the intersection between these two functions, which is one is what? Square root x minus 1, and the other one is y equal x. Y equal x. So actually I have 2 points of intersection. This is 1. And for sure they are more than 1. So if I choose, what will be f prime? Here, f prime will be 5/2 root x minus 1 minus 2. So I'll choose x1 to be 1.2. If I plug it, I will get x2 is 1.2457. x3 1.2500. x4 is the same. So this is what I want. This is the difference between them is less than 0.001. Also, I guess another one, if I choose to find the second zero, if I choose x1 equal 5, and that will be the answer, you will get what? You will get 0. You will get the answer. Okay. So I have x2 equal 5. By the way, how to find the zeros of this one? Very easy, huh? You just square both sides. That will be 10x minus 1 equal 4x squared. So you need to solve this equation, 4x squared minus 10x plus 10 equals 0. In other words, 2x squared minus 5x plus 5 equals 0, which is what? 2x. They have x. Yeah. Minus. 5/4. I have 5 and 5/4. How it comes? I don't know what I'm doing, Sheikh. This is not 1025. X minus 1 equal 4x squared. So 4x squared minus 25x plus 25 equals 0, which I can simplify. This is will be what? I have 4x times x minus 5 minus 5 is minus 5x minus 20 minus 25. So I have x equal 5/4 or x equal 5, which is we did. Huh? We get this and this. You can start with x1 equal 4, then you can do the iterations until you get 4. Okay. Now let me move to number 13. 13. F of x equal x minus e minus x. How to choose the starting point on the intersection between y equal x, y equal e minus x. This means the zeros of this. So we do this. This is e minus x, and this is y equal x. So what would be a good starting point? Maybe 0.5. We do that. Plug it. Yeah, I have f prime is 1 plus e minus x. So x2 will be x1 minus f of x1 over f prime of x1, which is for sure I need the calculators to do it. If you do the calculators, you get 0.5663. x3, still the difference is not less than 0.001. x3 is 0.5671. And by the way, x4 is the same. If you are using only coordinates. Okay, next one, 17. I need to find the 0 for this. 1 minus x plus sine x. What is good starting point? A good starting point will be, I can check the intersection of this with this. This is sine. No, I want to check the intersection between y equal 1 minus x and y equal minus sine x. Or, yeah, one should be, because I need to write it something minus something. So I can write it sine x minus x minus 1. So I need to find the intersection between this and this, which is x minus 1. At x, at 0, it's minus 1, which is something like this is sine, and this is, so a good starting point will be 2. You put 2, do the calculations, you get x2 is 1.9360. We need to find f prime. Huh? You understand what I mean by f prime will be what? Minus 1, or we can put it the other way, or yeah, which is what? Cosine x minus 1. Okay. So plug it, x2 is this, x3 equal 1.9346, and x4 is the same, 1.9346. Yeah, we'll stop there. Okay, point of intersection, this is explain it more. Now I need to find how to deal with, if I have the point of intersection between two functions, means I'm dealing with this function, the function which has the difference between them. So this one, my function will be tan inverse of x minus cosine inverse of x. So h prime is 1 over 1 plus x squared minus minus, so it will be plus 1 over square root 1 minus x squared. And the point which I will choose, my starting point, this is 1, so my starting point will be 0.5. So plug 0.5. You know, I'm talking about, I plug it where? I plug it in this. x2 equal x1 minus h of x1 over h prime at x1. So plug x1 equal 0.5. You will get x2 calculator. You need calculator to do this. It will be 0.7985. Then x3 is 0.7863, and x4 0.7862. So I will stop there. Okay, you want it to be less than this. Okay, same thing now for x and tan x, between x and tan x. So my function will be tan x minus x, and f prime is secant square minus 1, or x minus tan x. It will be the same thing. So my starting point, I will choose a starting point to be, actually I have two intersection, but I'm talking about this. I'm dealing with this. So choose x1 to be 4.5. So if x1 equal 4.5, plug it into this. No, not f. This is h, which is this minus, or this minus is the same. over h prime at x1. You will get x2 equal 4.4936 and x3 4.4334, which is what I want. The difference is less than 0.001. Okay. Now let me move to the next problems. 25, where there is a failure of Newton's method. 25 is what? I have the function is 2x cubed minus 6x squared plus 6x minus 1. Find the derivative. What you will get? 8x squared. No, what's 8? 8 comes from 6x squared minus 12x plus 6. If you notice, if I start with x1 equal 1, then f of 1 will be what? Minus 6 plus 6, 0. It will be 1. But the problem is f prime at 1 will be 0. So how to do this then? Cannot do this. So Newton's method fails. What I will do, I change my starting point. One idea. Okay. Let me do the second one. 26 f of x, x cubed minus 2x minus 2, f prime is 3x squared minus 2. I'm starting with this. So it will be x2. It will be x1 minus f of x1 over f prime at x1. Let me do it quickly. What will be x1? 0. F of 0 is minus 2. F prime at 0, minus 2, so that is minus 1. So it will be x3. It will be x2 minus f of x2 over f prime at x2. So I have minus 1 minus. F at minus 1, I have minus 1 plus 2 minus 2, that is minus 1 over. Substitute here, it will be 1. So I have minus 1 plus 1, which is 0. So what will be x4? If I plug 0, I'm getting minus 1. x5, 0. x6, minus 1. So Newton's method will fail. I will not go to something fixed. It will go up and down between 0 and minus 1. So Newton's method will fail to converge. Fixed point of, they're talking about fixed point. What I mean by a fixed point of a function, he said find the fixed point of a function, means we are solving this equation, f of x equal x. So 27, I want to solve this equation, f of x equal x, or cosine x equal x. So I need to find the zeros of this. So my function, which I will work Newton's method with, will be this function, where it's very clear if I have, this is cosine, and this is y equal x. So what will be my starting point? I will start with x1 equal 1. You plug it into x2 equal x1 minus g of x1 over g prime at x1. You get what? x2 will be 0.7540. x3 will be, what is it? 0.7391. x4 is 0.7391. This is what I want to find a good approximation. 28, the function is cotan x. So the fixed point, my function g, will be cotan minus x, which if I do the graph just to be sure, this is after the pi, do something like this, and this is y equal x, to find the intersection between these two. So I have starting point put the starting point to be 1. So I start with 1 to find x2 is x1 minus g of x1 over g prime at x1. I'll get x2 will be what? 0.8516. X3 will be 0.8603 and x4 0.8603, which is a good approximation. Now this exploring concept. What will be the values of future guesses if your initial guess is 0 of f of x? I have initial guess 33 is x1 is 0. The initial guess call it x1, and I know initial guess is 0 of f of x. I have f of x1 equals 0. Right away, what will be x2? This is 0. 0 or something. That will be x1. So what will be my future iterations? It will be the same. Always I'm getting x1. Future iteration will be x1. I plug x1, I get x1, x1, x1. So that's it. 34. It says what? Does Newton's method fail when the initial guess relative maximum? Relative maximum means what? F prime at x1 equals 0. So what will happen? And then f prime at my initial guess is 0. Newton's method will fail. How I divide by f prime? How we divide by f prime? Okay. Determine whether the zeros, if we have a function, p of x equal q of x, هل الzeros of f are the same as zeros of q of b? The answer is no. Example, take this one. This is p of x over q of x. The zeros of p of x are what? Are plus or minus 1. But 1 is not a 0 of f of x. So this statement is wrong. This is no. Not correct. However, if I put this, change the statement, and I make this reduced form, then this is correct. Then it's correct. Okay, 37. What is 37? I want to find approximated this. I want to approximate x equals square root of a, which means x squared is equal to a, which means x squared minus a equals 0. I want to solve this equation. I want to approximate this 0 using Newton's method. So my f of x is x squared minus a. What will be f prime? It will be 2x. So what is the relation xn plus 1, the Newton's method? Xn plus 1 will be xn minus f of xn over f prime of xn. He said proof it's equal to this. So let us do the calculation. That will be xn minus f of xn, which is xn squared minus a over 2xn, which is equal over 2xn squared minus xn squared plus a. And that would be what? xn squared plus a over 2xn, which is, I can take half outside. I have what? xn, I put in the same 4, plus it will be xn minus half xn plus a over xn, which is the same formula as this. So that is the formula. Now, what he wants, where n is 1, 2, 3, and so on. Okay. Using this method and the functions to drive this, we drive it. Now we want to do square root of 5. I want to approximate square root of 5. What I will do, I have xn plus 1 equal half xn plus 5 over xn. That will be 5. I will start with x1 equal 2. x2 will be what? Will be half 2 plus 5 over 2. And that give me what? 15 over 4. Correct? No. Not 15 over 4. It will be what? 4 plus 5, 9 over 2, 9 over 4, which is 2.25. Plug it again, I get x3. Now I need the calculator. x3 will be what? 2. I'm getting the numbers from the calculator. 2.2361. That will be x4 equal 2.2361, which is almost the same. Now if I square root the 7, I have xn plus 1 equal half xn plus 7 over xn. I'll start with 2. Do the calculations. You'll get now 2.75. You can check. Now do the calculator. x3 will be 2.6477 and x4 2.6458. This is x4. This is x4. x4 2.6458 and x5, which will be a good approximation, 2.6458, which is the same. It's a good approximation. Okay, last things for this section. True or false? 41. True. Why? Because if I want to solve this, square both sides and get fx equals 0. If I want to solve this, if I take the square root, then the square root of 0 is 0. So the solution of this is the solution of this, and the solution of this, solution of this. So this is okay. 42. He says what? If the coefficient of polynomial are positive, then the polynomial has no positive 0. Yeah, because if I have polynomial and let me do it here. I need some space. P of x, n x to the power n. He said if all of these coefficients positive, and if x is positive, I have positive 0, all of this should be positive. Impossible to be 0. There is no positive 0. There's a positive 0, then that cannot be cannot equal to 0. That should be always positive. That will be always positive. Positive times positive, positive times positive. The sum of positive will be always positive. So this is true. If x is cubic polynomial, then f prime is never 0, then initial guess, I know how he put it here. This is true, but to prove it is very complicated. 44. Newton's method fails when the initial guess corresponding to horizontal tangent. Horizontal tangent means what? F prime is equal to 0, which we know that Newton's method will fail. Because how I will find this? Problem here. 46. He's talking about this point. He need to find point of tangency. And this is the function. So like what we did before, how to find this point of tangency? We call it multiple names, x1 and cosine x1. So I'll find the slope of that tangent. You want to find to approximate the coordinate of point of tangency. To approximate this. So I know that the derivative is minus sine x. Okay. So f, to find this, I need to solve what? I need to find the m tangent will be minus sine x1 at this point. And m tangent, and this is passes through the point 0, 0. M tangent will be what? Cosine x1 minus 0 over x1 minus 0. So I have minus sine x1 equal to cosine x1 over x1. In other words, I have cosine x1 plus x1 sine x1, that is equal to 0. So this is the function which I want to approximate to find the 0. I need to approximate the zeros of this function, f of x, call it g of x. Okay, and I know a good approximation, a good starting point is 3. Since this is 3.14, a good starting point is 3. If you do this, I need to find g prime, use up Newton's method. I have x2 is 2.798, x3 will be minus 0.942, which will give me a good, no, this is not correct. 2 point, I think equal minus 3, and this is 46. Let me get the correct numbers. Yeah, I get x1 equal this, and this is y2 is minus 0.942, which is this one, almost around the minus 1. If I do more iterations, I get a good approximation. Yeah, let me finish by, I went also to this problem, review problems. I think we did something similar, so I'm not doing anything from there. But also I go to the problem solving at the end of the chapter, talking about the problem at the end of the chapter. So I will do these problems. Number 4. What is the number 4? He said, find the function of this 4. A plus B cosine CX. So I need to find A, B, and C. So I need 3 equations. What he gave us, that is tangent to this line, which is y equal 1, tangent to the line y equal 1, a tangent, okay, yeah, tangent to the line y equal 1 at the point 0 and 1. So it means 0 and 1 is part of the function. Satisfy the function. So 0 and 1 give me what? A plus B cosine 0 is 1 is equal to 1. So this is my first equation. Okay. And also it's tangent to the line, this at this point, tangent to the line, this line at this point. So this point also satisfy the equation of the satisfy the function, which is pi over 4, 3 over 2. So I have 3 over 2 equals A plus B cosine by C over 4. Okay. What else we have? I have this line, which means y prime, which means the slope. This line is tangent to the curve at this point. So I have m tangent, which is 1, is equal to y prime at pi over 4. What is y prime? F prime of x is minus b sine cx. Okay, so the third one, I have y1 equal y prime at pi over 4, or also have it from here. That's y prime at 0 is 0. Y prime at 0. Y prime at 0 equals 0. That will give us nothing. Well, so that will not help. Y prime at 0. Give me 0 equals 0. I'm getting nothing out of it. But this y prime at pi over 4 will be 1. So that means 1 equal minus b sine c pi over 4. Okay, so I need to solve these three equations. I need to solve these three equations. Okay. Three equations, three elements. So from here, I know that B equal what? Minus 1 over sine C pi over 4. Okay. And from there, I need to solve these three equations. We not do it this way. Yeah. A equal this. So I plug this in this one. I get what? 3 over 2 will be equal 1 minus b plus b cosine c pi over 4. In other words, I have minus b plus b cosine c pi over 4 equals to half. So I plug it here to get what? One minus b, so that will be 1 over c sine c pi over 4, 1 over c. Now where is the c? 1 minus b. When do the derivative, there is a c. There is a c missing, sorry. Where is the derivative? There is bc here. Yeah, should be a c here. So this is c. 1 over sine c pi over 4 plus 1 over minus. It would be minus minus 1 over C sine C pi over 4 times cosine C pi over 4 equal to half. In other words, that means this is sine, so I have 1 minus cosine, 1 minus cosine C pi over 4 equal half C cosine C pi over 4. I'm solving this equation. Rearrange it. The problem is that many values of C will work. One answer. So any C satisfying this, you get C, then you plug it here, you get the B, you plug it here, you get the A. So one answer, many answers I have here. Many answers. So one answer, if C equal to, I'm getting B equal minus half. I'll leave it for you to do it. And A equals 3 over 2. So one function will be 3 over 2 minus half cosine 2x. Also, you can try other C's. Many answers you will get. Let me do the last question, which is actually 3.7. This one I do it because to find, just for you to find these relations. But the function is very complicated. The calculation is something else. Now let me finish by this one, which is number 10, which is 3.7, about 3.7. Yeah, very easy, not that difficult. I have y equal cube root of x, which is x to the power 1 over 3. That implies dy by dt. It's a related rate, so I need to find dy by dt anyway. 1 over 3 x minus 2 over 3 dx by dt. Part A. How fast is what he gave us? What are the information given? When x equal 8, the y coordinate is increasing at this rate. So I have dy by dt equal 1 when x equal 8. Okay. So when x equal 8 means y equals what? 2. Just plug it here. You get y equal 2. So part A, he wants how fast is the x component changing. So I want the dx by dt equal what? Give it this. Let's plug it here. I have 1 equal 1 over 3, 8 to the power minus 2 over 3, dx by dt, which is what? Which is I'm looking for. So this is what? I have 1 equal 1 over 12, because this is cube root of 8 to the power minus times 1 over 4, that 1 over 12 dx by dt. It means dx by dt will be equal to 12. Part B. How fast is the distance from the origin changing? I want the distance from the origin to the point x and y. What is the distance? Square root x squared plus y squared, which is x minus 0 squared plus 0, y minus 0 squared. So now what will be the rate of change of d? It will be 1 over 2 root x squared plus y squared times 2x plus 2y. Okay. Now, just substitute. So the rate of change, dd, no, uh, 2x, I'm doing that in terms of t. 2x dt plus 2y dy by dt. Now I plug the numbers, which is equal what? 2 times 8 times dx by dt, which is 1 over 12. Okay. Is it? You know what? The 2. So that gives me x dx by dt plus y dy by dt over this square root. So now x is what? 8. Dx by dt, 12. Y is 2. Dy by dt is 1 over square root. Yeah, calculation only. 8 square, 64, plus 1 square, or 2 square, I mean, 4. And that give me what? 8 to 12, 8 to 12, 96 plus 2, 98 over square root of 68, which is this one, root 17 with 98. So that gives me 49 over square root of 17. And that is the answer. So the only things, the distance, this is what I'm looking for. So just differentiate it and substitute. Okay, I think I will stop here. That's, I think, enough for this section 3.8 and also the what do you call it? Yeah, 3.8. Thank you.